I'm back and refreshed and ready to go. Okay, hypothesis testing for proportion. Now, just a little bit more background about what you are going to do in your work. You're looking at first at variable 10, but then 11 through 17 as well. And in variable 10, we're looking at, oh gosh, I'm sorry, what was it? The ease of returning goods? Yes. And what the person did, the survey taker, is choose a value of 1, 2, 3, or 4. And 1 would be the best, would be Springdale Mall, 2 would be downtown, 3 would be west, and 4 would be, I don't know, none of the above or something like that. And so if we just looked at the 3 malls and forgot about that 4th category, none of the rest, we could say that we would, what your author is asking you to do is say, if all of the malls were the same, we would expect each of them to get a value of, or to get a proportion of 1/3 of the votes. 3 malls, 1/3 for each. And that is going to be your null hypothesis, that the proportion, the true proportion is, true population proportion is equal to 0.33333, 1/3. However, when you put together your data, you will see that it's not equal to 0.3. Of course, we simply are drawing from a sample, and that's why we're doing hypothesis testing. We're going to test and see whether or not the each mall did receive 1/3 of the votes, or whether it's something else. Now, I did something similar, and what I've done in my data is I decided to take a look at the top 4. I'm going to leave out the 5th category, and so if I look at the top 4, I used my count function. I'm sure I did somewhere. There it is over there, and then I copied the data here, and or count if function, just to determine. Of course, you know, we did frequency distributions back in week 1. You can also go back there, and if you don't want to use count if, but I just find it so much easier just to type in count if, show the range and which value we want. 1, 2, 3, 4, 5. Okay, anyway, now here's a trick. I'm looking at 4 of the 5 values. And so I can't use all 50 of my values in making this proportion, because votes for 1 through 4 only got 40 of the votes. Likewise, you will find that you can't use 150 as your denominator when you calculate these proportions. By the way, what did I do here? I simply took 8 divided by 40, and this one is 12 divided by 40. But I would have made a mistake if I would have said 8 divided by 50. So catch that one in doing your work. You're going to be looking at only the top 3 ratings, and you're going to have counts of those and sum those top 3 to have the value that you divide by for each of those numbers 11 through 17. By the way, you're going to be generating a lot of numbers in this exercise. You know, here's one problem. You're going to do how many? 3 of them. You're going to have all that. Here's one problem. You're going to do 11 through 17. That sounds like 7 of them. You're going to be doing like that. You're going to have a lot of numbers. And I suggest that you carefully just put them all in a table. You might want to show me examples of your equations or talk about which equation they were in the text. And you know what? It's Christmas. Here's a gift for you. I am not going to be super critical about APA. Now, I'm not saying give me junk. I want a little introduction. I want a little conclusion. But yeah, let's slack off just a little bit. This is difficult work, and you're asked to really think about this stuff and make sense of it. So APA is, well, truth be known, I don't know that it belongs in a math class at all, but I don't make those decisions. So anyway, I'm going to let it slide a little bit this time. So make tables though. Put all this data in a table. It'll be much easier to look at and for you to analyze. And it'll also be easier when I look at your papers to see it all and compare it to my answers. Okay, now what are we doing? I'm looking at the top three, and just like in your problem 2, you're going to be looking at Springdale, which happens to be number 1, and you're going to be looking at Springdale's proportion in all of these variables 11 through 17 to see if Springdale really rocks as good as we know Springdale does. And in fact, you will, well, you'll find out. Springdale is going to continue. I mean, the statistics show it, that we are not going to find out that Springdale all of a sudden has gone to pot. No, your statistics will show you that Springdale proportions are not equal to, I think, let's see, as I recall, Springdale's proportions are always going to be pretty high. Let me double check that. Hold on one sec. What I stated was correct. Springdale's proportions are going to be quite high, 0.5, 0.6, 0.8. And when we compare it to, let's see, you're going to use 1/3, not 1/4. I have 4. You're going to have 3. You'll use 1/3. I'm using 1/4. When you compare those high proportions to 0.25, you're going to end up rejecting often. And that tells us, hey, Springdale's special. Although you might have an exception or two in there. I forget. I think there's, yeah, Springdale had a couple shortcomings, right? Or at least one of the other malls had beat Springdale in a couple factors, or one factor at least. Excuse me, I don't recall. But anyway, all right. Our equation that we use for making hypothesis tests for proportions looks a little bit different. It uses the z-statistic. And let's see, I'm looking on page 356. It's testing the proportion, the z-test with test statistic. And how does that equation look? Well, we create a test statistic. It's going to be a z-test statistic. And we take our proportion and we subtract the hypothesized population proportion and divide by, let's see, the standard error of the distribution, which, it's kind of complicated. Under the square root sign, we have the hypothesized proportion times 1 minus the hypothesized proportion divided by n. And that's all I've done here. So let's see. First of all, I had to get a critical level, and for these you were told to use the 95% level of significance. So we know from our page 277, wasn't it, or something like that, that the z-statistic for the 95% level, yep, 277, is 1.96. That's going to be our critical level. We're going to be comparing our value to see whether it falls inside of 1.96 or outside. N is 40. I said that was critical. You're going to have to come up with a new n for each of your problems when you're doing variables 11 through 17, because it will vary. All right. My null hypothesis is that the true population proportion is equal to 1/4. Do they look like 1/4? Let's see, 20%, 30%, 17.5, 32. Well, that's right. I'm only looking at this one. I'm looking at the true population proportion of rating 1, and that one is pretty close to 1/4. I bet it'll turn out to be, well, let's see. My test statistic, what did I do? I took M11, where did M11 go? That's my proportion, minus my hypothesized proportion, 0.25, divided by, and there's that big ugly thing. You might want to do this in several steps in your spreadsheet, make it easier for you. It's the square root of 0.25, the hypothesized proportion, times 1 minus the hypothesized proportion, divided by n. What's this guy sitting out here? I'm not sure. Don't like him, go away. And yeah, you wrap that whole thing up, and sure enough, I got minus 0.703. Now, why is it negative? Well, it's because of this numerator. We're taking M11, the sample proportion, and subtracting our proposed or our hypothesized proportion, 0.25, and it makes it negative. So put that in terms of the z distribution. Remember, there's two ends of it. There's a positive end and there's a negative end. And this value is simply falling. Well, let's see. My critical value is on the right 1.96 and on the left negative 1.96. Where does negative 0.073 fall? Well, it falls in the middle to the right of negative 1.96, doesn't it? Uh-oh, something's going on here. Why do I say reject? I think I was copying and got a little crazy with copying things. I'm going to get rid of that and get rid of that color because I think that should be yellow, right? That tells us we should accept that guy. Yes. Right? See if I have that straight. Think I do. Yes. Negative 0.73 falls inside of or more towards the middle of negative 1.96. And so thinking about our t distribution, that's well within the accept H0 region. And so what do? We say we accept H0. Yes, our sample proportion said that the proportion of rating ones were 0.2. We proposed that the true value of the population was 0.25, and our statistics say yes, we should accept that null hypothesis, and we should fail to reject that the true population proportion is equal to 0.25. Very good. Let's do another. Let me set one up. I don't have one more set up here. Give me a sec. Oh, where's the right button? Okay. This time I got a little crazy. I said, okay, we could not reject the null hypothesis when we said the true population proportion was a quarter. That's really close to the sample proportion. That's why we couldn't reject it, why we accepted it. How about if we say the population proportion is 0.5? That's quite a ways from our sample proportion. And I ran the numbers. There's my equation. I just had to change my 0.25s to 0.5s. Everything else stayed the same. I'm still looking at M11, right? Yes, okay. And it said now my calculated test statistic is negative 3.79. Now, how does that compare to negative 1.96? Oh, that's out towards the tail, isn't it? In this case, we're not going to accept that sucker. No way. We're going to reject. Paste. Color. There it is. We're going to reject H0. We do not believe, based on these statistics, we cannot say that the true population proportion is equal to 0.5. Not when we had a sample proportion of 0.2. Statistics say it's not so. Okay, folks. Once again, I hope this has helped you. Some of you have been calling me. Some of you have been writing. I prefer the phone calls. It seems easier. It takes a lot less time sometimes if you have problems to walk through something. But please, if you do call, be prepared for the call. Have your questions in mind. Have done your homework. And then, if you've done that, I'm very happy to help. All right. Is there anything else I can think of here last minute? No, I think we're set to go. Week 7. CT assignment. Let's get her done.